Welcome to aminacademy.com. In linear algebra, let us discuss about vector space. A vector space or a linear space is a group of objects called vectors added collectively and multiplied. That means addition and multiplication is satisfied here by numbers called scalars. Scalars are usually considered to be real numbers, but there are few cases of scalar multiplication by rational numbers, complex numbers, etc. with vector spaces. We can define the vector space detailedly. A space comprised of vectors collectively with the associative and cumulative law of addition of vectors and also associative distributive process of multiplication of vectors by scalars is called vector space. That means here it satisfies for space comprised of vectors collectively with the associative and commutative law of addition of vectors and also the associative and distributive process of multiplication. In both addition and multiplication, such associative, commutative properties and associative and distributive properties for multiplication of vectors by scalar is called the vector space. Vector space consists of a set of V, that is element of V are called vectors, and field F, element of F are scalars. Normally we are keeping set of V is element of vectors, all vectors, and field F, elements of F are scalars and two operations. Vector addition is an operation that takes two vectors, that is U and V are element of V, that already we defined V, and it produces the third vectors U plus V is an element of V. That means U and V are individually element of V, then we can say U plus V also in the element of V. Scalar multiplication is an operation that takes a scalar C is an element of F and a vector V is an element of V, and it produces any vector UV, that is the product of scalar with vector gives the element of vector, where both the operation must satisfy the following conditions. Element of V are mostly called vectors and element of F are mostly called scalars. There are different types of vectors. To qualify the vector space V, the addition and multiplication of operation must stick to number of requirements called axioms. Here we have to understand clearly the difference between vector and vector spaces. Vector is a part of a vector space. That means vector space is a broad collection and vector is a space, part of that vector space, whereas vector space is a group of objects which is multiplied by scalars and combined by the vector space axioms. We have to understand 0 is a vector space. A trivial vector space represented by 0, that is set 0, is an example of vector space which contains 0 vector or null vectors. That means 0 vector is in a vector space. In this case, the addition and scalar multiplication are trivial. Equal vectors. Two vectors are said to be equal if the vectors which have the same magnitude and the same direction are called equal vectors. That means you know that vector having magnitude and direction, if magnitude and direction is equal for two vectors, then we can say these are two vectors. Mostly when two vectors are equal, the addressed line segment are parallel. That means if you draw a line for the vectors, that both vectors comprises a parallel. There are parallel. Also their vector column are identical. Vector space axioms. Some axioms are there in vectors. An operation in vector addition, that is plus, must satisfy the following conditions. Closure property. We know that x and y are any vectors are in vector space, that element of x and y are element of V, then x plus y belongs to V. Then commutative law. We know that commutative means here x plus y equal to y plus x. That is changes the position. Associative law. We know that x plus bracket y plus z, we can say then x plus y first added, then z is added next. Additive inverse. That means if add with x with 0, then it gives x itself, so it's having additive identity is a 0. Additive inverse. For each vector x in V vector space, there is an additive inverse, that is minus x, to get a solution of V. That means we know that x minus x equal to 0, then it gives 0 vector. Then we can say x minus x is additive inverse of x and x is additive inverse of minus x. That means if added both, it gives 0 vector. Condition to scalar multiplication. An operation scalar multiplication is defined between a scalar and a vector, and it should satisfy the following conditions. That is additive operation of scalar multiplication. We know that if x is any vector and c is any real number in the vector space, both are in the vector space, then we have associative law in multiplication of scalar with vector. Here c dot d into v is equal to c dot d into v. That means that is position is changed. That is c is a constant with some vector, then dot vector. Then we can say c is multiplied with first this d vector, then it is multiplied v vector. Distributive law. For all real numbers c and d, here this d is a scalar here. That means c and d are the vector x is in element of v, then we can say c plus d is a two constant added and dot product with v. You can say the distributive. C is distributed with v and d is distributed with v. That is cv plus cd. Distributive law. For all real numbers c and the vector x and y, and that is in element of v, then we can say c dot x plus v equal to cx plus cy, where c is there for all real numbers c here, c is any real numbers. Now unitary law. For all vectors x in vector space, then we can say 1 into v equal to v into 1 equal to 1. That is here 1 is unitary vector. That means 1 is multiplied dot product with v and dot product v multiplied commutative with 1, then equal v vectors only. Vector space, some properties we can discuss about vector space. The addition operation of finite list of vectors v1, v2, v3 up to vk if it's possible. Second one, x plus y is 0, then it should be x minus y equal to minus x or x equal to minus y. The negation of 0 is 0 itself. It means minus 0 equal to plus 0 only, because no condition for direction for 0 vectors. The negation of negative is positive. Negation of negation, that is minus of minus equal to v, and x plus y equal to x. If x plus y equal to x, then we can say y equal to 0. That means 0 vector is added with y, x, it gives x only. Then product of 0 into y 0 itself. That means 0 is multiplied with any vector gives 0. For any real numbers c, any scalar times the 0 vector is also 0. That is c into 0 is 0. If the value of cx equals 0, that means we can say c is 0 or x equals 0. Both can be 0 or any one can be 0. It satisfies cx equals 0. The scalar value of minus 1 times the vector is the negation of the vectors. That means minus 1 into x is minus x. That is minus 1 is multiplied with vector. It's a negation of that x vector. Like addition also, x minus y can be represented x plus addition of negation of y. X minus y is x plus negation of y you can represent. All the normal properties of the subtraction follows. Same, x plus y equal to 0 here. Then we can say x equal to z minus y. It's normal algebraic way also it is. C into x minus y is c is distributed, cx minus cy. Here some we can explain some problems in vector space so that each of the condition provided is in vector space. Here the set of linear properties, that is P1 is polynomial, P1 is equal to A0, A1x, A2x, A3, x3, like it continue. Then we can say addition and scalar multiplication operation is possible here. Under usual matrix operation, the set of 2 into 2 matrix with real entries. Here for example, that one, the 0 element of the vector space under 2 into 2 matrix is also 0. That means 0 element is in matrix space, then vector space also it have that zeros. Like here the closure property of addition involves. That means here if set of A equal x, y, z, w or element of suppose R4 of x plus y minus z plus w equal to 0. That means R4 means 4 variables under the operation of R4. Then we can see similarly the closure of scalar multiplication can be obtained. Here we discuss theoretically the detailed explanation of the vector space. In further videos we will do detailed problem solving and further what is R4 space or cube space, like we can explain further videos. We have done. Please subscribe our YouTube channel.